My aim with this video and accompanying book is to provide you with an easy and accessible way to make carbon prints. Easy means one emulsion, one negative, one exposure, and one transfer. Accessible means using inkjet negatives. To get to that point, we have two problems that we need to overcome. Those are the stability of the dichromate and the tonal threshold. So let's look at these. When I started printing a little over a decade ago, I was using dichromate sensitized emulsions, and my prints would either come out too dark or too light or too dark again. And it was just insanely frustrating because dichromate is not stable. You have the dark reaction, so it's changing sensitivity before you expose it. And then after you expose it, you have the continuing action of light. So it's really hard, unless you're very consistent in your workflow, to get a well-calibrated print. The way we're going to get around that is to use DOS. So DOS, or at least a variation of it, has been used for over 120 years. It's stable, so I can mix this in with the emulsion, and I can expose it a day later, a week later, a month later, a year later, and my result is going to be the exact same. I don't have to worry about changing sensitivity. So it's going to make that part of the process a lot easier. The second problem that I run into is this tonal threshold. So let's say that I expose a platinum print I cut a strip of emulsion and expose it from 0 to 30 seconds. Well, I should have a nice smooth transition from paper white into the tonal range. But with carbon printing, that's not the case. Here, I've got 0-second exposure and then nothing, 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 and then it very abruptly goes into tone. I call this the tonal threshold. And in a print, that's going to give me something like this, where we're going to see blown out highlights is the issue. More blown out highlights. So this is a very common issue we see in carbon prints. There's a number of ways to minimize this. One is to reduce the contrast. So if we were to reduce there's about 15 ways I can reduce contrast here. The most common are going to be to increase the amount of dichromate or to decrease the amount of pigment. So if I were to put less pigment in here, well, then this is going to be less, it's going to be lighter, right? So it's going to be less noticeable. Another way around this is to, let's say that this is kind of to the left of this is the safe zone. So if this is a dangerous zone here, blown out highlights, if we start our whites kind of like this print here, where the whites are starting at that kind of 20% gray or something, then I'm able to retain that information there. We get muddy highlights. Not really good either. Another way we can get around that is adding grain or micro contrast. So this is where you see a lot of carbon prints of forests, of rocks, are going to be much easier to print. So choosing what you print helps, or adding grain some way. And adding grain, if we take that to the extreme, that's what I'm doing with halftone negatives, where I don't have to worry about this issue. But with image setter negatives, halftone negatives, they're not accessible. They're hard to find in a lot of places. And so we're trying to make a workflow that is easy and accessible. Accessible is going to be inkjet negatives. So the other way around this is to do this in multiple layers. So if we take a look at this print here, this one, I've got a high contrast film here that I'm trying to print some snow, and I bracketed this way, kind of increasing the exposure. And you see here this really abrupt transition between the snow and the highlights. If I were to expose it longer, yeah, I might be able to maintain some information. But look at how dark that snow is getting. That's not going to work. So I can reduce the pigment, as I said before. So if I reduce the pigment, I have a much lower contrast emulsion. And here now I'm getting beautiful information in the snow, but I don't have good blacks. So what do? Well, combine them into multiple layers. So here I have a high contrast film, which I bracketed vertically, and then a low contrast film I bracketed horizontally, put these one on top of each other. And so if I expose that low contrast film emulsion for 7 minutes and then another one for 2.5 minutes, I can get something that might look a bit like this. And then, of course, we can do duotones. We can do dodging and burning in each of those layers. If I wanted more separation here, well, I could expose the bottom for 3 minutes, or the whole thing for 3 minutes, cover this up, and then expose this for 7 minutes. And then the background here is going to be lighter. So if that's lighter, I'll get more separation between the trees and I can get a print more like that. So there's a lot of stuff you can do with multiple layers, but we're still going to have this tonal threshold in between each layer, so it might not work on all prints. It's a lot of work calibrating this. It took me, if I were to do this now, it'd probably take me 3 or 4 days to calibrate, correctly a single print, which is just not what we're looking for here. We want this to be easy. So I kind of took this a little bit further with Printmaker Strand. This is kind of alternative to gum printing. And you can do this with gum printing too, where I'm building up tone in multiple layers. So here I have the first layer has a very low amount of pigment, and then I'm increasing pigment each time. And then I'm also decreasing the exposure. So longer exposure puts it further into the highlights, shorter exposure into the shadows. I combine this together and I can get a full tonal range, and I can get a print from an inkjet negative. And I can make a print like this in about 45 minutes, which is, very easy, very fast. Inkjet negative, so it's accessible, but I have to register. So if you have to register a print, that adds complexity, plus you have to do a little bit of math to do this. So we want something that's even easier than that. What I've come up with are these variable contrast emulsions, where we are going to kind of combine what is a multi-layer print into one emulsion. So emulsion that has a high contrast, medium contrast, low contrast, all in one emulsion, that we can then just do one negative, one exposure, and then one transfer, and we're done. So it's a little bit more complicated making the emulsion, but once the emulsion is made, then we're good to go. It took me a little while to figure out how to make a good emulsion. So I started research on this a few years ago, did a couple weeks, and then I think I did another week at some point. And then now in 2025, I spent about 6 weeks on this. And the results are just absolutely fantastic. So let's look at some prints. So here, print of a flower. Here we have 0 to 10% gray. Just really good transitions there. Here's a print of my wife, a print of kind of up in the northern Minnesota, and then some dunes. I really like this print. If you can see that transition there in the highlights, I mean, that goes to like 1% gray. It's almost to the paper white there. So just super smooth. And this I made this emulsion about 2 weeks ago, and then did a little bit more research, and I've improved even on this. And that's the recipes that I've put in the book. But take a look at this. I mean, so this is my most recent one. So I don't know if you can pause the video here and look at how smoothly that transition. I mean, it's just incredible, and really deep blacks. And this one I could have exposed for longer. And with this one too, I don't know if you can see this. It has like almost, I can feel these numbers here. So it's got a really high relief on there, really smooth, deep black. Here's the curve for this. So a really long toe. And then I could expose this for longer, and I could have got up to a Dmax of about 2, luminance value of, probably 8, 9, or 10. So really fantastic prints. So what I want to show you now is how to make these variable contrast emulsions. So let's go over here. And our first step is going to be to measure out some gelatin. So I've got 2 different kinds of gelatins. And this is going to be important. I have a gelatin for the base. And what we're going to do is, it's not really a variable contrast emulsion. I've simplified this even further. And what we're going to make is a supercoated emulsion, where the supercoat is going to hold on to the highlights of the base when we develop it. When we flip it over, it's going to kind of hold on. And it's maybe not as good as variable contrast, but this one here that I showed you, this is just a supercoated emulsion, which is much simpler to make than a true variable contrast emulsion. And to make this to work, it's really important that the gelatin that goes on the top layer, so what we're going to do is we're just going to pour a simple emulsion like you normally would. And then on top of that, we're just going to pour a layer of clear gelatin. So it's just really simple. The only requirement is that that top layer is very thin, it's very even, and that the speed of that emulsion is about a stop faster than the base. So I found two gelatins that work really well together. I have this base gelatin that I'm going to sell on my website. The only problem is I only have about 20 kilos of this and it's not manufactured anymore. So I'm going to sell this and then it's kind of gone. Once this is gone, the second best one I found is Restoration Type 1 from Gelita. You can get that from Kramer or G&W. I'll put a link in the book. It works quite well, not as well as this. So I'll try to find one that works even better. And then for the top layer, this is just Restoration Type 2 from the same company, from Gelita, which you can buy from GMW or super overpriced at Kramer. So and kind of what I'm talking about here is if we don't get the gelatin right, we're gonna get things like this. I mean, the transition is just terrible. So this is putting a soft gelatin on top of a hard gelatin versus a hard gelatin on top of soft gelatin. We can get a much smoother transition to the highlights. So the gelatin is very important at this step. I'm going to measure out for the base layer here. Actually, start with the base layer. And I'm going to do about 1 liter here. So we're going to do 50 grams of gelatin. And here, I don't have to be super precise, but I want to be within about 1 gram or so. The top layer, I want to be very precise. But this layer, that's plenty good. And then we're going to do, I usually do about half the amount of whatever my weight of gelatin is. I do half that of sugar, but I'm going to do 1/4 of that. So I'm going to do, if I did 50, I'll do 12.5 grams of sugar here. 12.5, more or less. And then of water, so we want to use deionized distilled water. I'm going to do 600 grams here. So I've got 2 recipes in the book. I'm doing this really low contrast one, which will require longer exposure, but it gives me a nice high relief, which is kind of cool looking. So I'm going to go for that. So, because usually I do my recipes to 1 liter, but we're just going to do this to 600. And then we want to add a biocide to this. So we can either do cinnamon, works really well. So just normal, so you can get cinnamon extract or cinnamaldehyde, dilute this 10% of that in alcohol, or I use Cathan. So I'm just going to do about 2 drops of this, 1, 2, and that's going to be good. And that will keep any bacteria from growing in that. And then at the same time, I'm going to prepare the top layer. And I could label these, but it's going to be pretty obvious which is which. So for the top layer, I'm going to do 9 grams of gelatin. And this one I do want to be very precise, because if there's any variation in this top layer, it will give us a variation in our print or calibration. So that's probably good. Now, close enough. And then a liter of water. So this is only 0.9% gelatin. So it's very, very low, because we're going to make pretty thin layer. And this, when this dries down, it's going to very, very thin layer on top. And also the amount of water here has to be precise as well, because this is going on top. So if we do more or less water, our coating will be thicker or thinner, which we don't want. So we want this to be quite precise. Okay. And we could add another little bit of cast onto this one, just a drop or two. Yeah. And now this gelatin, we want to let it bloom for at least an hour. I have some gelatin that I prepared earlier. So this gelatin has been sitting here for, well, I made it yesterday, so plenty of time. And now all we need to do is heat this up. So then melt it. So I'm just going to stick this in a microwave. If you want to use a hot water bag or something, but for me, microwave is the easiest. So I'm going to set this for about 4 minutes, and we'll come back in 4 minutes and continue with making the emulsions. The gelatin has melted now. So there's no clumps of gelatin floating here. It looks really good. I've let this cool down a little bit. So I heat it up to about 120 degrees Fahrenheit to melt it, and then I let it cool down to about 100 degrees Fahrenheit, and then I'm going to add the DOS and the pigment. DOS is sensitive to light in its dry form, unlike dichromate. So we're going to change lighting here. And then we can measure out 1 gram of DOS for the base layer. The top layer doesn't have any DOS. It's nothing. There's no sugar. It's just 1.9% gelatin. That's it. We will add a little bit of alcohol to it later. DOS, less toxic than dichromate, but I do like to wear, I had a Duke University toxicologist kind of analyze it. So less toxic than dichromate, but I still wear gloves. I wear a mask when I'm measuring it out, just to be safe. So I'm going to measure out 1 gram for this amount. So that ends up being about only 2% DOS. So it's a very, very low amount of DOS. I'm using a low amount of DOS because one of the byproducts, as it's exposed, is nitrogen. So I don't want to create too many nitrogen bubbles. Where normally I'd be using about 5 or 6%, but in a very thin layer with halftone negatives. But for this, I'm going to lower it quite a bit. That's close enough. And then I can just add this directly to that. Sometimes I'll add a little bit of water to it first, but it's fine to add like that. And then pigment. So I'm using Talon's Indian ink, and I don't know if I have a bottle. Yeah, I've got a bottle of that. So this is my favorite ink to use. But you can use any pigment you want, especially this, because staining is not an issue. Because we're doing a super coating, then staining, you can use any pigment, and you don't have to worry about that. And it's a little bit warm, so I'm going to do, I've got one here that's a very kind of cool tone. So I'm going to kind of mix these up a little bit. And I'm doing 1.8 grams of pigment. Oh, just Talons. 1.8 there. And I like syringes to just store pigments. And if I'm doing tones, I can mix up a certain neutral tone or cool tone or warm tone, sepia tone, and then just store in a syringe. And then it's easy to measure out after that. And I want to measure up to 2.5 grams total. So 2.5 double drop. And then to this, I want to add water here. A little bit of water first. And then I always want to add my gelatin little by little to the pigment. If I add the pigment directly to the gelatin, then it can flocculate, plump up, which isn't ideal. And then we'll just go back and forth a couple times. I'm not worried about making bubbles or anything at this point. And then we'll give this a stir for about 30 seconds or so. Make sure that all that DOS is dissolved. And I just love being able to use DOS because with dichromate, normally you can't mix it in unless you add sodium hydroxide to kind of keep up the pH, because it would just harden kind of spontaneously if you were to mix it directly in. Well, with DOS you can mix it directly in, so you skip this whole sensitizing step, so it's a lot faster in the process. Plus your prints are a lot more even. So that sensitizing step, there's just so many things that can go wrong, and errors that you can introduce into your system. And this just minimizes those errors a lot. So it really simplifies the process. So DOS is awesome. All right, so we're pretty much done here. I just need to filter this and measure it into containers. But before I do that, I'm going to let that sit a couple minutes. And while that's sitting, I'm going to prepare my emulsions here. Get my gloves off. The support for my emulsions, I'm using Synapse, 450 gram OM. If you want to use Yupo, you can. Your emulsions are going to curl a lot more, but you can use any support, X-ray film, whatever works for you. Doesn't matter. Let's do this side. So I can fit about 5 on here because we are going to cover these up with trays. So actually we'll just do 4. I think I can fit 5, but 4 will be enough for now. And you saw that I spritzed the table, and the table is also, it's glass, it's very flat. I've cleaned it so there's no gunk and stuff underneath. I've treated this with Rain-X, but I want to find something else besides Rain-X because I don't really like using forever chemicals. But that just prevents, if there's a coating of Rain-X on here, when I pour my emulsion, if I go all the way to the edge, it's not going to kind of flow all over the place. So it's a lot easier this than I see people doing like frames and stuff, and this is just very simple. And then I spritz this so that I can get them to lay down very flat and kind of stick to the table, so they're not going to be moving around on me. So I'm just going over with a roller, fairly heavy pressure. I really like these rollers that I can get my palm on there. And then just squeegee off the table. And then I'll grab a lint-free rag and dry this off. So very easy prep. If you want to label these for whatever, because variable contrast, what is it, 30th of August, you could, or put the recipe on there that this has, 2.5 grams of pigment per 10 grams of gelatin, 2% DOS. You could write that information on here. I'll write that on after the emulsion is finished. The size of this, I don't have a ruler here, but this measures 36 centimeters by 45 centimeters. So I'm going to coat this to a wet height of 1.2 milliliters. So 36 by 45 by 1.2 gives me about 195 milliliters. I just do everything in grams. So when I filter and measure out my gelatin, I'm going to measure out 195 grams. So let's do that. So grab some beakers. So this is why I have a lot of beakers for doing this system compared to, coating it with a rod or something. I need lots of beakers. And I'm just going to filter this out. So gloves on again. And the temperature on here is probably about 90 degrees Fahrenheit right now. If I filter this too hot, I tend to get a lot of micro bubbles. But if you do get micro bubbles, don't worry about it too much. I'll show you how to get rid of those as well. Ooh, too much. I haven't done that in years. Oh, all right. So we are going to, and if you do spill gelatin, I could come here and clean this up right now. So this is a good learning experience. But if I just let this sit up in about 5 minutes, then I can just scrape it up. It's a lot easier. So I'm just going to let that pool just kind of sit there. And we're going to measure out 195 grams of emulsion. So about, doesn't have to be exact. So I got 198. If it's plus or minus 5 grams, that's plenty good. Okay. So I have 4 emulsions for 4 sheets over there. I've got enough emulsion here to probably make another 4 or 5 more, but I'm not going to worry about that right now. I'll do that later today or tomorrow. And I've got some ethyl alcohol here. I like using ethyl alcohol compared to isopropyl alcohol. There might be some micro bubbles along here. So there's 2 ways you can get rid of micro bubbles. One is to kind of give it a little spritz. So go back and forth on there and give that a little spritz. Another way to get rid of those is to swirl. So I can swirl that, and that will get rid of any micro bubbles. And then if you still notice that there's some micro bubbles in there, we can stick it in the microwave and heat it up back up to 110, 120 degrees, and then let it cool down, and there'll be no micro bubbles in that. So let's do that. Although these are looking pretty good, but I want these to be absolutely perfect. So if we look at this here, you can see that there's just a couple there, not much of anything. But I'm gonna heat them up anyways, because if there are any defects on this first layer, it's gonna cause problems for that second coating. So I'm gonna heat those up, let them cool down. That'll take about 5 minutes, and then I'll show you how to coat these emulsions. My emulsion is ready to go. It's about 100 degrees Fahrenheit. I don't want to pour this too hot. If I pour it too hot, I'm going to get ripple marks. If I have ripple marks in my image or in my emulsion, when I go and coat this with a second layer, those ripple marks are going to be in the second layer, and then I'm going to see those in the print. So that's not good. So we want it to be at the correct temperature. My room temperature right here is about 21 degrees Celsius. So we don't want it to be too hot or too cold in here. We want this to set up in about 30 seconds or so. If it's a lower percent of gelatin, it'll take a little bit longer, but this will set up pretty quickly because this is 9% gelatin. Give a little stir. I'm going to pour this about in the center, maybe a little bit kind of like a line. And then I'm just going to let this expand outwards. If you notice that it's expanding too close to the edge before you've poured out all the emulsion, then you can come with your comb and adjust. But we're just going to go like so. And I'm going to try to move it out towards the edges, and then I'll come back and make it look nice. So I've got it towards the edges now, and now I'm going to make it look nice. Not that it's really necessary because it's not going to be part of our image, but I'm a little bit OCD, so. And then I'm going to check for any bubbles. No bubbles, that's why I have this light up here so I can check. And I'm going to immediately cover this with a tray. If there's any dust that lands on this, that's also going to affect our second layer. We're going to have a divot there. That divot, it's going to be a little bit thicker on our second layer. And that's going to turn out as a light area in our print. So we want to make sure that this is very clean. So clean studio and then immediately cover this up. I'm going to let this sit for about 15 minutes and then I can do my second layer. Let's prepare the second layer, our super coat. This is the 0.9% gelatin that we prepared earlier. This is the GMW type 2. And I'm not going to need all of this. So I'm going to measure out about 200 grams of this for those 4 sheets that I need. Because I'm going to add alcohol to this. So I don't add the alcohol until I'm ready to use it. So let's measure out about 200 grams or so. Oops. Open there. And we got a little bit extra here, so let's get rid of some. Even a little bit less. That's about 200 grams. I want to be fairly precise on this. And then to that, I'm going to add alcohol. I'm adding pure ethyl alcohol, ethanol. I don't want to use isopropyl alcohol. I don't want to use denatured alcohol. So either get some Everclear from the wine store or whatever, alcohol store, whatever those are called, or from a laboratory supply. They'll have pure ethanol. And then I'm going to use 25% weight. So whatever this was, so if it was 100 grams of gelatin, then I'm going to do about 25 grams of alcohol. So this was 200 grams, so I'm going to do 50 grams of alcohol. And this is just this, but it's easier to measure from here. So I'm going to measure out 50 grams. And again, I want to be fairly precise with this. And just a little bit more. Okay. And then we'll give this a little stir. And then alcohol is just going to make it coat a lot easier, that second coat. Note about the alcohol, we don't want to have too much alcohol in our air. I think OSHA standards, you can have about 2 grams of alcohol per meter cubed. I've got about 60 meters cubed back here, so I can have about 120 grams of alcohol in here. Is fine for an 8-hour workday. You just don't want to get up too high. You don't want to be breathing a lot of ethyl alcohol. And then, so figure out how much you can actually put on here. If you don't want to use alcohol, you can just do this with just water as well, but it does coat a lot easier with the alcohol. And then my coating thickness, I'm going to, of actual gelatin, it's about 0.3 millimeters, but with the alcohol, it goes up to 0.42 millimeters. I'm just doing this all by grams. So if, obviously with the alcohol, it's going to be different, but I just do everything by grams. If you're consistent with that, then it doesn't matter for your calibration. So everything by grams. So I'm going to measure my emulsion here, the coated area. So about a centimeter less than the coated area. So mine was about 33 by 43 centimeters times 0.42 gives me 53 grams. So I'm going to measure out 53 grams of this. And I might grab a syringe to make this a little bit easier, but let's see. Oh, accurately, I can do this. This one I do want to be within a gram or so. So 53, I think that's close enough. So I'm going to measure out these 4. And then we'll coat the second layer. So you don't need to watch this. So once I have this measured out, then we'll come over here and coat this. I'm now ready to do the super coat. For spreading the emulsion around, I've tried the back side of a comb. Obviously, the front side wouldn't work, so I damaged the gelatin. Back side of a spoon. But by far, the best method to do this is with a puddle pusher. So get one of these glass coating rods, puddle pushers. It is awesome. It makes this process just so much easier. So we're going to take this off, and we should have just a nice smooth surface here to work on. I'm going to pour just kind of a line from top to bottom. And then with a puddle pusher, I'm just going to push that off to one side and the other. And then down here. And don't get too close to the edge. We don't want the gelatin kind of going all over the place. And then with your finger, you can bring it up to about a centimeter away from the edge. So not all the way up to the edge, just a centimeter is good enough. And that looks good. And if there is like a little bubble there, I can get rid of that. Or there's a hair there or something. Move that to the side. And then kind of need to be moved around a little bit, and it will level out. So I'm going to put this on top, and I do want a little bit of air movement underneath here. So I'm going to raise this up a little bit. So put some speakers there, and then I've got a little bit of airflow, but no dust is going to land on that. So I'll do the other 4, and then this will set in about an hour or so. So if you want this to set faster, you can do thinner layers. But thinner layers, they're more prone to showing errors if there are, little pieces of dust or something that land on that first layer, or if it's not perfectly level. That's the other thing about this method. If your glass isn't perfectly level, that first layer kind of levels everything out. So that's really nice. Once this is set up in about an hour, we can just hang this up, let it dry, and then we're ready to go to the calibration step. Our variable contrast emulsion or supercoated emulsion is ready to go. Now we need to go through the process of calibration. So calibration, I think most of you already know how to do this. I'm going to go through it really quickly, and maybe I have a few pointers that are going to be helpful. The first step, we're going to break this down to 3 or 4 steps. The first step is going to be to find a convincing black, or how black, your deepest black should be. Don't get too obsessed with this. I've been doing a lot of visiting museums for my book on gum printing, and this was a print by. So I have these kind of strips that I was holding up to prints by. This was one by Desmaché, and this was his black, and I mean that's it's not even like middle gray on this range here, but it's a beautiful print. So don't get too obsessed with getting just a super deep black. You just want a convincing black or whatever looks good. So we're going to do that by exposing a Stouffer step wedge or by bracketing exposures. Once we have that kind of base exposure time, we are going to figure out what inks block best. So if you have QTR, print out one of these test charts, or with Peter Mars, easy digital negatives, something like this, or with Pisography, or if you kind of set up all gray inks. And we're just going to expose that for whatever time you figured out on this, and we'll get something kind of like this. Then we're going to read these values, and whether we're doing Peter Mars method or QTR and QTR, we're just going to read these. And if we just want to do one ink, well, I'd be about 85% of black inks gives me a nice tone range. I'll just use 85% black, and that would be my negative. I make a negative, so let me grab here. So something like this. And then expose it with my emulsion, and I will use that to create a linearization. I'll go through the linearization here in a minute, and then we're ready to make prints. So again, I'm just going to go through this really quickly on kind of PC and Mac. And then after this, I'll actually go through the process of making a print. So take your emulsion, and we're going to put this on top of whatever film you are using. So come over here. So if you're using Picto Rico, or this is one from Siebdruck in Germany, you just need this base, because if you don't have that base, your exposures are not going to be kind of relevant to what's going on. So I'm going to put that there, put my emulsion on top of that. And I do like to do this when we work with inkjet negatives under some film, but for this, we don't really need that. So I'll put that there. And then I will turn my vacuum on, and I'll expose this for a pretty decent amount of time. If I overexpose, that's fine. I can always kind of subtract exposure from there. But if I underexpose, then I have to do this step again. So once this is exposed, I'll take it back and process it as I normally do. And again, I'll go through the processing of this film in a little bit here. So the result of that is going to be something like this. So take a look here. I want to be able to kind of see a little bit of difference between these. And I can't really see much of difference between 1 and 2 and 3. So this one's probably maybe a little bit overexposed. Like I don't need that extra exposure. It's just going to make calibration more difficult. So in this case, I might reduce it by a stop or maybe 2/3 of a stop. This one, I could even expose it a little bit longer. So this one, I could expose it for maybe another stop to get a little bit deeper black, but this is probably good enough. So let's say that this was, in this one was 4,000 units. Let's say that I'm going to expose this for this emulsion here, and let's say that's 2,000 units. That is irrelevant to you. Yours is going to be different. You might be doing yours in time. A unit of mine is not a unit as yours. So you have to figure out how long that exposure needs to be. Once you have that, then we'll come over to QTR here. So I'll record my screen. If you're on Mac, it's going to be pretty similar. It's slow recording. So I'm going to open up QTR. And we're going to go to curve creation. And then on here, actually, no, we're going to go to options, calibration mode. And that will give us a little test chart up here. And we want to set this to 2888 super unidirectional, whether you're using photo ink or matte black ink. And then I'm just going to press print. And that's going to print out my calibration chart here. So we'll get a calibration chart like this. And all I'm going to do is, obviously it'll need to be the emulsion a little bit bigger than this. I like to put this behind a very thin film. So I'm going to put this behind this film. That will keep the emulsion from sticking. And obviously this emulsion would need to be a little bit larger. We'll put this on here. And if you wanted to mask this out as well, kind of add a safe edge, you could mask this with a couple pieces of black film, ruby lith or something. But I'm going to kind of forget that now. And then we will do the exact same before. So whatever your exposure time, I think I said 2,000 units. I'm going to turn my vacuum on. And then I'll set this to 2,000 units. So 2,000. Okay. And then I will expose this for 2,000 units. So we're not going to go through the whole exposure here. So stop. Once that's done exposing, I will take it back and develop this onto whatever paper support I'm going on to. In this case, I just did this on Yupo, but ideally you'd want to do this on paper. Once I have this chart here, let's go back to the computer. And I'm going to record this on the computer screen here. And all we're going to do is read the values here. So we're going to open up our i1 Pro. And we don't need all of this here. Let's go to, this is fine. So spot measurement. And this has some measurements from before. So let's get rid of this. So let's just open this up again. So we have new measurements here. And we don't even really need to measure this, but if we're just doing one ink, but this will work just fine. So I'll go to measure chart, and 1 Pro 2, and next. And then spot, calibrate, and you see I've got this on, it's got a little tile under here, and that's just calibrating the spectrophotometer. If you don't have a spectrophotometer, you can just scan this, take a photo of it, will also work. And so all we're looking for here is, is there a difference between 80, 85 here? So come in and look at this. So here we're just looking for the ink that the blocks at the best. So like mine's going to be a little bit different from yours. So I switched my inks out here, and I've got 10 different inks. So the light magenta is really, it's like a really high UV blocking ink. So that blocks too much. The black actually looks pretty good. We want something that blocks maybe about 100% ink. So I think that looks pretty good. So we'd want about 85% if we just wanted to do one ink. And our goal here is just to make a QTR curve. So I'm going to come here to curve creation, and I want to use just black. So I'm just going to go to gray ink here, set that density to 100, limit to 85. And then my gray curve, I'm going to set height to 0, shadow 0, gamma to 1, and file save as, and we'll save this as black only 85, save. And then if I go back to options, we don't want to be in calibration mode anymore. So if I open up this curve, so black only 85, you'll see that this is just a straight line more or less. And it should be a straight line. We have had black boost to 100, so we don't want any black boost on here. So file, save. So make sure that the black boost isn't adding more ink. And now it should just be a straight line. So that'd be just with one ink. But if we want to smooth this out a little bit more, on the Pictorico, I can print up to about 160% ink. And if you think about this as, okay, if we do one ink, it's going to be a little bit grainy, but if we add in another ink, it's going to it's going to block. So let's say if we added this magenta here, and we add 60% magenta, well, it's going to block up to that point. And then the black on top of that, those black dots around those dots, because inkjets aren't necessarily, they're not completely continuous tone. It's kind of like half continuous tone, half tone. So we want to kind of trick our eyes into seeing that as continuous tone. And so we can do that by layering up those inks. So the more ink we can put into the shadows of our negative, the smoother our highlights are going to be. So to do that is pretty simple. So let's say that we want to replace some of this black with that magenta. So let's say that we read here and at 30. So let's go here, and that 30 gives me a lumens value of 28. Well, all I need to do is find on this magenta here what gives me 28. And let's go even lighter. Let's do light cyan. So let's see where 28 happens on this light cyan layer. So that one's still too dark. So let's go even lighter. 26 and 29. And let's see, 95 here. 28. So if I print 95% light cyan, that's going to be the same as, I think I did 25% black. Just double check that. Nope, I did 30%. Yeah. So 30% light black is giving me the same result as 100% light cyan. So what we can do is just replace that 30% black with 100% light cyan. So I'll do that by coming to the curve creation utility again here, and we'll go to light cyan, and we'll go to, this time to toner, because we don't want to be using the same kind of gray ink. Density, we'll just set that to 100 again, and we're doing 95% here. And then we want to subtract 30, because we're replacing 30% of that ink. So 85 minus 30 would be 55. And then go to the toner curve, and we want to set the highlights and shadows to 0, and file, save as. And we'll save this as black only. This is black. We'll do black 55 and cyan, light cyan, 55 or 85, 95, 95. Save. And now, if we open up that curve here, light cyan, and we have a black boost on again. So we need to make sure that we're not doing that. So black boost needs to be at 55, and file, save. And now we'll get 2 straight lines going up, and these will add up to about 150% pigment, which is fine. So this would be, you give us fairly smooth highlights. Then we're just going to open up File, select Image, and open up a test chart here. And with this curve, go and print it with the same resolution speed as we did before. And then we have our test chart, and we can go on with our linearization. So that's how I'm going to do that on the PC. On a Mac, let's open up the Mac here. Unfortunately, none of the screen capture worked on Mac, so I'm recording this separately. So on Mac, we're going to open up the iProfiler software. If you have another software to get lab values, that works. But this is what I use. So we're going to do 3 rows by 21 steps. Next, and calibrate. And larger. All right, so what I'm going to do is read the ink blocking test chart from the most blocking ink to the least blocking ink. So, and really I'm just going to do 3 inks here, because that's all that Richard's software, which is what I'm going to be using, allows. It'd be nice if we could do, 8 inks, and there are some, there's a person working in MATLAB that allows you to do this, but for now, this is good enough. So we're going to do black, light black, and light black. And I'm going to read these from the most blocking. So this would be the white in our print to the least amount of ink. So this would be from white to black. And I already have these red, so you don't have to sit here and listen to me read through all those. So again, it's the most blocking ink, so black, and going from the most amount of ink to the least amount of ink, so from white to black in your print. And then we're going to go to save. And I'm just going to save this as my desktop, and we'll save this just as a text file. And all we want is the lab values here, so we don't really need anything else on here. And okay. And we can take a look at that file. It gives us kind of 3 files here. We don't need these. So let's open this up. And it gives up a bunch of other data. I like to just kind of clean this up. So I just copy and paste this into another text file. And then I have just something clean that I can put into Richard's software like this. So we're going to open up the quad tone profiler software. And if I try to open up the readings that I just did, the program just crashes, even though the readings are perfectly normal. So if I try to open that up, they're too close together or something, the densities. So the program just crashes. So at some point, I don't know, this program is trying to divide by 0 or something, and it just doesn't work. So I chose three inks that are a little bit further apart. A little bit better separation, and that works a little bit better with this program. And okay. And what we want is a good separation of tone here. So I'm just going to kind of move these over until And let's change these to my printer model. We're going to do the P3880, which I think works in this one here. And black, light black, and light black. And I want to kind of move this over, maybe move this one up until I see kind of a good separation of tones here. And then I would like to have more overlap into the shadows, and I can kind of play with the ending overlap here, but at some point it's just going to kind of crap out. So I can go up to about there. And then I'm going to save this as, let's just do it as quad video, save, and replace. And then we're going to, and we could, in that curve creation, we could go to edit curve, but I like to just save it and then go to the quad editor utility, open up that curve, and then I'm not saving over it. So I can open that up. And here we want to smooth this out a little bit. And that's what I really like about Richard's software, is the ability to kind of smooth out these curves without having to manually put these into Excel and do a lot of extra work. So light black, and there's a lot of points on here, so we're just going to kind of backspace, backspace tab, backspace tab, backspace tab. Actually, not that many. Reset. So we just want to remove a couple. I was pressing the wrong button here. And let's move this up a little bit. Down. And probably get rid of that point too. And that looks a little bit better. So accept. And so that's a little bit smoother going into the shadows. And then we can save this as quad video. Let's do smooth, save. And then we need to install this. So on a PC, it just kind of installs automatically, but here we need to go to applications and carry this over. So let's grab our quad video smooth over into here. And then we want to install that. So install command, and that's going to install that curve. Then we can open up print tool and our test strip. And what's great about Richard's software is it almost comes out linear after this. So we can almost skip the linearization step, but I will still do it just to make sure. So you want a test strip, whether it's this or a square, something to give you data to make a linearization. So this all looks good. No color management, 16-bit mode, run print. Run print. Okay. And then we can go to quad tone rip and then open up. So the 16-bit here, curve 1, and then we'll open up that quad video smooth and make sure that all these are exactly the same as when you made the ink density chart, that none of these settings are changed. And then go ahead and print it. Once you have that test chart, so this test chart will come out of your printer, whether, either of those. Then all we have to do is print this. So again, we would put this underneath our film here. And obviously cut this a little bit smaller. And then I'd expose this, close this up, expose this for 2000 units, same time that we figured out in that first step, onto the paper that I am going to finally print. Very important for this step. And we'll get something that looks something like this. So now let's look at how to linearize this. And linearizing on PC and Mac is going to be the exact same. So I'm going to stop the recording here. And we'll go over to the PC. And I'm just going to open up my profiler software again. And let's go back. So let's go home and go to measure chart. And we're going to use the i1 Pro 2, and we're going to do rows 1, columns 21, and next. And I'll go through this, and my chart here, it starts, and once we're calibrate again, let's calibrate this again. Calibrate. I'm going to do every 5% increase. So it says 0, 1, 2, 3, 4, 5. I'm going to skip them, go 0, 5, 10, 15, 20, and I'm going to go through the whole series of steps here. And again, it's important that you do this on the final paper support. If you change supports, I mean, calibration is not going to be that far off, but ideally you want it to be on that final paper support. And 100. I'm going to save this data now. And we'll just save this as, I don't know, linearization for video. And save. And okay. And then when I open up that, so this is desktop. What do I have this under? I'm printing with, no, I think I've got it under calibrations, inkjet, various readings, and linearization video. Open this up, and all I want is this data here. So I'm just going to copy this, and I'm going to put this into this SCTV, the spot color tone value linearization. So just copy and paste that in here, and it's going to give me my input output values for my linearization. If you're not really familiar with this, I did write a book on calibration, so kind of all covered in there. And then we're going to open up Photoshop, file, open recent. Let's see if no. I'm going to open a test chart, carbon useful documents, and just do a test chart gray gamma 2.2. And all I need to do here is add a curves adjustment layer. So curves. And then I just need to put in these input output values. So here it kind of goes up quickly. So I'm going to add a point at 10. So if I grab this hand here and I click on that, then it's going to add a point here. So 10, and then look at the output is 19. So we're going to change that to 19. And then it kind of goes over and crosses maybe around 30. So I'll add another point in at 30. So looking at the output over here, so input, output. So this is 32. And then I'll add in a couple more points. Let's add in one at around 85. Let's do 90. So 90, 73. And then 75, 59. Oops. 59. And let's do 55, 55, 45, and then maybe add one more in at 95, 95, 84. And this curve looks a little bit funky, so I want to even this out. So I'm going to just use my cursor here to try to kind of smooth out any bumps here. And I might kind of move this down a little bit, add a point in there. And that looks pretty good. I can hover over these and see how close they are. So if I hover over this, it gives me, so come over here. So it gives me, 10, 18. And I can check over here, 10, 19, and then I can kind of hover back and forth. So this is okay at 20. This is coming out as 20 and 27. So I can see 20, 27. That's good. So I can hover over and see how close my curve is. I'm going to save that curves preset. And we'll just save this as linearization for video and save. Now we're ready to make prints. So now I can open up a file. So open up a print here. So files to print. And I've got one here. Let's see. So I've got a print here. And I've added a margin to this. It's the size I want. So you want to go to image size, make sure this is the correct image size. You want to make sure that any sharpening or anything else you need to do. Only thing I might say that your screen. So I'll come over here. The screen here, that it's not too bright. So if it's really bright like that, it's not going to really match what your print is going to be. So I want to have this more, closer to kind of the color of my paper. And okay, return. And all I need to do here is go to curves and load that curve that I just made. So curve, and then go to invert, and now I have my negative. I can save this, file, save as, and we'll save this as, photo, video. Let's just do video to print and save, and okay. And then all I'll do is go back to QTR, file, select image, and I have video to print, open, and make sure that fits. And then I'll open up that curve that I used before, print, and I'll get a negative that looks a bit like this. If you are in Mac for printing, you just have to do this in Print Tool. So I'm not going to record the screen. So from here and take a look at the screen here. And so all I'll do is open up my image here. So let's get rid of this one and let's just open up. I don't know if I have anything here that I had. Yeah, I don't have any images on here, so yeah, maybe a downloads there or something. Here, Inkjet take test image. There we go. So I'll load this image after applying my linearization, and then go to run print. Go to quad tone, 16-bit, grab my curve that I made before, and print. And you get your negative. Just make sure that this is set to the same settings that you had before. All right, so let's pause here, and then we're going to run through how to actually make a print. Now to have some fun. To make a print, we just need three things. We need the emulsion, the variable contrast or super coated emulsion that we made, the negative, and an exposure time. So I'm going to take the negative that I made. I made this one with QTR. And my Epson P7000 or 700. And I don't have to worry about registration because it's just one layer. And I am putting this very thin mylar on the top here. And I could stretch this out a little bit more, but I think it'll be fine. And then I'm just going to place my emulsion on top here. And actually, before I do that, I'm going to mask it out a little bit more. I have about a centimeter, half, maybe 2 centimeter margin here, but I'm going to make a little bit more. So something like that. Less to clean up. And then I'm going to place my emulsion on here. So it's probably about centered, and about centered here will be about that there. So about there. I could measure this out, but that's good enough. And then I have to put a little bit of mosquito netting just because my rubber doesn't have any texture on it, so to get a good vacuum. And then so I've got a good vacuum on here, and there's no registration, no nothing. It's okay, and it's not in there totally straight. I don't care. just as long as the image is kind of lined up in the center of my emulsion. I don't want to get in too close to the edge because of how I'm pouring it. And then I'm going to expose this for the time that we figured out at the very beginning of our calibration step, which was 2,000 units. So I'm going to expose this for 2,000 units. That'll take about 15, 20 minutes. And then we'll take this in the back and continue with the next steps. And there's the end of the exposure. My exposure is controlled by ELEAT's LT6 Flight Controller 6 units, which is a fantastic integrator. So it's controlling, there's a sensor up here that is reading how much UV energy radiation is being received and controlling my exposure that way. You can do it with time as well, but this is just going to be a little bit more reliable using an integrator. And again, ELEAT's integrators are fantastic. Let's go on to the back. I have some water prepared here, and it's about, should be around about 72. Right now it's about 75, but that's fine. And I'm going to soak this. All I'm trying to do is make this sticky. The amount of moisture that gets absorbed into here, if we think of this kind of as a graph of stickiness, as we soak it longer, it gets very sticky. And then if you soak it even longer, then the stickiness kind of goes down. So we want to kind of be at that peak, but also we want to be able to peel it when we peel it apart. So there's kind of a point where those two meet. So it's really important that we soak this for the correct amount of time. If you notice it's very hard to peel, well, soak it for longer. If it's very easy to peel and you get frilling, then soak it for less time. So I'm going to soak it for about a minute here. Okay, so that's about a minute. Pull this out. And then I'm just going to squeegee. And we can kind of see our image a little bit there. We're going to let this rest for about 10, 15 minutes for the nitrogen to release. You don't want to trap that between our paper and the gelatin. So 15-minute rest, and then we're ready. Actually, before we start that, so while this is resting, we want to start soaking our paper. I've got kind of two papers here. I've got just watercolor paper that has been coated with gelatin. That will work just fine. But we want to make this as easy as possible. So doing all this sizing and stuff like that, it's extra complication. So Hanamiel Fine Art Pearl works perfectly right out of the box. In fact, it works even better than this. The adhesion of this paper is just insane. So we can really reduce the amount of pigment here, do very high relief things, and not have to worry about frilling and bubbles and stuff like that. So it's really fantastic paper. And I don't have to do anything with it. It's just pull it right out of the box. And then while that is resting here, I'm going to put this in the water, and that's going to soak for about 10, 15 minutes as well. The emulsion and the paper have been soaking for about 10, 15 minutes now. I'm going to take the paper out of the water, transfer it to my table, and I'm going to roller this into place. If you don't have a roller, you can just use a squeegee or just a PVC tube. And then I'm going to flood this with water. Grab my print, which will land up about there. And roll that into place. Get rid of any excess water. And then with just a rag, dry off the edges a little bit. And that's it. No need to put weights on top of this. In fact, even the pressure of the roller, that's too much weight. I have another method. You can, with small pressures, pull them out, but I've got a slightly more complicated method that doesn't put any pressure on these, which is really what you want. You want these to come together with no pressure, or else you're going to get a little bit of texture from the paper. But this paper is so smooth that it's not really much of an issue, so I'm fine doing it with the roller. But ideally, we don't want to have any pressure, so just leaving it like this for another 15 minutes for the water content into here to kind of equalize. Then we can go and develop. The paper and emulsion sandwich has been resting for about 10 or 15 minutes. I'm now going to put this into hot water. When I put it in the hot water, I want to make sure that the paper is on the top side. I'll let this rest for a few seconds before I peel it apart. About 10. And the reason I have the paper on top is because I want to keep this completely submerged underwater as I peel the two apart. And I can keep them submerged by kind of walking my fingers along the bottom here. This is the emulsion that's going to be thrown away or washed and reused. And my paper with the photograph is on top here. And now develop. Developing just takes place in hot water, nothing else. Temperature of this water is 43 degrees Celsius, so about 112 degrees Fahrenheit. I'm going to pull it in and out of water a few times, trying to get rid of these ridges or peel marks, pull marks, whatever you want to call them. That way it will develop a little bit more evenly. And then I'm going to flip this over and develop it face down a little bit. And you can still see pigment running down here. So I'm going to keep it in the hot water here a little bit longer. I find hitting it on the edge of the tray makes it develop a little bit faster. And then these shakes are they're very small shakes. We don't want to do huge shakes or else we'll get some frilling. And that's looking pretty good. There's no pigment running there. So I'm going to run the second bath here, which is a little bit cooler. This is about 100 degrees Fahrenheit, about 38 Celsius. And we don't really see much pigment running down here, but I'm going to develop it anyways, just to be certain. I'll pull it in and out of the water a few more times. But the print looks really good. Smooth gray backgrounds, skin tones are some of the most difficult things to print. That's why I chose this as a test image. And then finally, to just not necessarily cold water, but just whatever comes out of the tap. So this is about 72 degrees Fahrenheit, 22 Celsius. I normally don't do cold water baths, but for these variable contrasts, I think it does help a little bit to keep pigment from running. And if there's any, places where some emulsion or light got through the negative, we can kind of erase those. And then hang it up to dry. Once this is dry, then we can do the bleaching, clearing step, and our print is finished. The print is more or less dry at this point. We are going to continue with the bleaching step. This is to remove any of the sensitizer stain that might be in the emulsion or in the paper and prevent any future staining. So first, I'm going to put it into a bath of potassium permanganate. This is about 3 grams of potassium permanganate in 5 liters of water. So that's about 0.06%. So it's a very low percentage. And I'm just going to rock this back and forth for about a minute. while this is rocking back and forth, the second bath that I'm going to put the print in is sodium metabisulfite. I just kind of eyeball it, but it's about 15 grams in 5 liters of water. And the potassium permanganate, I reuse it. I'll put it back in this afterwards. I'm just careful not to contaminate it with other bath. But the sodium metabisulfite, I make that fresh each time I use it. Well, that should be good. And you'll see it has a very yellow color. Almost sepia. But when we put it into the sodium metabisulfite, it's going to go to white. And so I'll rock it back and forth in here until it goes to white. And then I'll continue for another 30 seconds to a minute, just to make sure that everything has been cleared out. That should be good. Let this drain a little bit. And then I have a third bath of just plain tap water. And usually in this bath, I'll let it sit for about 5 minutes. And then I'll go to a second bath of just tap water for about 10 minutes. So a 5-minute rinse and then a 10-minute rinse. For sake of time for this video, I'm just going to hang this up and say that we're finished, but then I'll come back and clear it some more. And there you have it. An easy and accessible way to make carbon prints. If you want to see more videos like this, please click subscribe. I sell DOS on my website. So a very good high purity DOS, which is what makes the emulsion stable as an alternative to dichromate. And then I've written out all the instructions and a little bit more detail in a book, chapter for a book. It's about 20 pages long, which can also be found on my website, which is www.thewetprint.com. Thank you very much for watching, and I really truly hope that this information is going to be useful to you.